In the depths of World War II, while the world burned, Nazi Germany was conducting some of the most sophisticated technological experiments ever conceived. Many of these innovations were so advanced, so ahead of their time, that the Allied powers took extraordinary measures to ensure they remained hidden from the general population. Some were destroyed, others were seized, studied in secret laboratories, and their development was restricted through international agreements that remain classified to this day. The question is not whether these technologies existed. The evidence is undeniable. The question is, why did the world go to such lengths to suppress them? Today, we examine 15 Nazi technologies that were so groundbreaking, so revolutionary, that they fundamentally changed the course of human innovation. These are the devices, the weapons, the scientific breakthroughs that redrew the boundaries of what was possible. Welcome to a history that has been carefully compartmentalized for over 80 years. The V-2 represented the world's first true ballistic missile, a weapon so advanced that it would not be matched by any other nation for years after World War II ended. Developed under the direction of Wernher von Braun at Peenemünde Army Research Center, the V-2 was a 14-ton vertically launched rocket with a range of approximately 200 miles and a top speed of 3,500 miles per hour. When the V-2 was launched from the French coast toward London and Antwerp in Belgium, it entered a flight trajectory that carried it to the edge of space, over 50 miles in altitude, before descending toward its target. This was something entirely unprecedented. No other nation possessed such technology. The missiles traveled so fast, at such altitudes, that they could not be intercepted by conventional air defense systems. They simply arrived without warning. Between September 1944 and March 1945, Nazi Germany launched approximately 3,000 V-2 missiles against Allied targets. Each contained a 1-ton warhead. Each was capable of destroying an entire city block. The psychological and military impact was profound, not because of the number of casualties, though those were significant, but because the Allies realized they were facing a weapon that represented the future of warfare. After the war, both the Soviet Union and the United States moved immediately to capture V-2 technology and the scientists who had created it. Operation Paperclip brought Wernher von Braun and over 1,500 German scientists and engineers to the United States. The V-2 blueprints and components formed the foundation of the American space program. The Redstone rockets, the Saturn rockets that took men to the moon, all of these descended directly from the V-2. The technology was so revolutionary that the world's space age was essentially built upon the V-2 platform that the Nazis had developed in secret. What remained unspoken was the question: if Germany had not surrendered, if they had possessed 2 more years of development time, what would the V-2 have become? While the V-2 was a ballistic missile, the V-1 was something different. It was a cruise missile, the ancestor of all modern cruise missiles that exist today. Called the Doodlebug or Buzz Bomb by the Allies because of the distinctive sound of its pulse jet engine, the V-1 was a revolutionary piece of military technology. The V-1 was an unmanned aerial vehicle that could be launched toward a target and would fly itself to that destination on a predetermined course. This was the world's first operational cruise missile. Thousands were manufactured. Thousands were launched against London and other Allied cities from 1944 onward. The genius of the V-1 was its simplicity combined with its effectiveness. It was cheaper to produce than a fighter aircraft. It could carry a significant warhead. It could be launched from simple facilities along the coast of France. At its peak, over 100 V-1s per day were being fired at southeastern England. In total, 9,521 V-1s were launched during the war. The V-1 technology was seized by the Allied powers after the war. The cruise missile concept that the Nazis had pioneered would become one of the most important weapon systems of the Cold War and beyond. Today's cruise missiles, whether American Tomahawks or other variants operated by nations around the world, all trace their lineage directly back to the V-1 flying bomb that was developed in Nazi Germany during World War II. The technology was so effective that it remained in active use throughout the subsequent 7 decades. The Messerschmitt Me 262 was the world's first operational jet-powered fighter aircraft. When it entered combat in 1944, it was capable of speeds that no propeller-driven aircraft could match. Flying at over 500 miles per hour, the Me-262 was essentially untouchable by conventional fighters of the Allied powers. The development of the Me-262 represented a fundamental breakthrough in aviation technology. The jet engine itself had been developed in Germany by Hans von Ohain, who had patented his design in 1936 and achieved the first flight of a jet-powered aircraft, the Heinkel He 178, in 1939. This was years ahead of equivalent British and American jet development. The Me-262 was armed with four 30mm cannons mounted in its nose. A single burst could destroy a bomber aircraft. Pilots who flew the Me-262 claimed they could penetrate bomber formations with impunity, inflicting devastating casualties before the Allied fighters could react. Had the Me-262 been produced in greater numbers earlier in the war, had the technology been refined further, the entire air war over Europe might have developed differently. But production was limited, and many aircraft were destroyed on the ground before they could engage in combat. After the war, captured Me-262s were studied intensively by American, British, and Soviet engineers. The technology directly influenced the design of post-war fighters, including the North American F-86 Sabre and the Boeing B-47 Stratojet. The jet engine revolution that would define aviation for the remainder of the 20th century had its roots in Nazi Germany's technological advancement during World War II. The question that military planners grappled with in secret briefings was stark. What if Germany had possessed more time to perfect this technology? While the Me-262 was a fighter, Nazi Germany was also developing jet-powered bombers. The Arado R-234 was the world's first operational jet-powered bomber aircraft. It flew faster than any conventional fighter of the period, making it nearly impossible to intercept. The R-234 first flew in combat on August 2, 1944, conducting a reconnaissance mission over the Allied beachhead in Normandy. Subsequent variants were equipped with bomb racks, making them capable of striking targets deep within Allied territory, with a speed that no defensive system could match. The R-234 was limited in numbers. Only approximately 200 were produced before the war ended, but its significance was tremendous. It demonstrated that jet propulsion could be applied not just to fighters, but to larger aircraft intended for bombing and reconnaissance missions. Captured R-234s were extensively studied by the Allied powers. The technology directly influenced the development of American jet bombers, including the B-45 Tornado and the B-47 Stratojet. The jet bomber concept that emerged from Nazi Germany would define strategic aviation throughout the Cold War and into the modern era. Among the most futuristic of Nazi technological achievements was the Horten HO-229, a flying wing design that incorporated features that would not become standard in aviation until decades later. The HO-229 was designed as a jet-powered bomber with a sleek, triangular profile that minimized its radar cross-section. In other words, it was designed to be invisible to radar detection systems. The technology employed in the HO-229 included special coatings and structural designs intended to absorb radar signals rather than reflecting them. This was stealth technology, conceived and tested in the 1940s, nearly 4 decades before the United States would introduce the F-117 Nighthawk stealth fighter. The HO-229 never entered full production. Only prototypes were constructed. But the concept was revolutionary. The idea that an aircraft could be designed to avoid radar detection, to make itself effectively invisible to the defensive systems of the opposing side, represented a fundamental shift in military thinking about aircraft design. After the war, the Horten design specifications were seized by the Allied powers. American engineers studied the flying wing concept extensively. The influence of the Horten design is evident in the development of the American B-2 Spirit stealth bomber, which also employs a flying wing configuration to minimize radar signature. Nazi Germany's submarine force was formidable throughout World War II, but near the end of the war, they developed a submarine so advanced that it represented a revolutionary departure from all previous submarine design. The Type 21 U-boat incorporated features that would not become standard in submarine design until well into the Cold War. The Type 21 featured an advanced snorkel system that allowed the submarine to run its diesel engines while remaining submerged at periscope depth. It had an enormous battery capacity that allowed it to remain submerged for extended periods. Operational reports indicated it could remain underwater for 17 days, nearly 3 times longer than previous submarines. The Type 21 was faster underwater than previous submarines were on the surface. Its hull was streamlined for underwater performance rather than surface performance. Its systems were integrated in ways that had not been attempted before. The Type 21 entered service too late in the war to have significant impact on naval operations. However, after the war, both the Soviet Union and the United States obtained Type 21 submarines and either operated them directly or reverse engineered them to develop their own advanced submarine designs. The technology represented in the Type 21 directly influenced submarine development throughout the Cold War. The implications of the Type 21's capabilities were sobering to Allied naval planners. Had Germany possessed more submarines of this advanced design, had they possessed them earlier in the war, the Atlantic convoy system might have been devastated. As early as 1939, Nazi Germany began developing the first practical night vision devices. The technology, codenamed the Zielgerät ZG-1229 Vampire, employed an infrared illuminator coupled with an infrared-sensitive detection system. This allowed soldiers to see in complete darkness by detecting heat and infrared radiation. The Vampire system was fitted to approximately 50 Mark V Panther tanks, which saw combat on both the eastern and western fronts. Man-portable systems weighing approximately 5 pounds were mounted on STG-44 assault rifles for use by infantrymen. The technology was crude by modern standards. The Vampire systems were heavy, required significant power, and had limited range, but the concept was sound. The Nazis had invented thermal imaging and infrared detection technology during World War II. After the war, this technology was seized and studied by the Allied powers. The development of modern night vision devices and thermal imaging systems that have become standard in military operations worldwide traces its lineage back to the Vampire systems that were developed in Nazi Germany. Nazi Germany's Navy developed a revolutionary coding technology for submarines designed to reduce their acoustic signature, to make them quieter and therefore harder to detect by underwater listening devices and sonar systems. Anechoic tiles, as they became known, were first applied to a German U-boat in 1940. The tiles were constructed from specially formulated materials that absorbed sound waves rather than reflecting them. This reduced the acoustic noise signature of the submarine, making it more difficult for Allied anti-submarine forces to locate and track it. The anechoic tiles were tested on operational U-boats, and their effectiveness in reducing acoustic detection was demonstrated. After the war, this technology was captured and studied by the Allied powers. Modern military submarines of all nations now routinely employ anechoic tile coatings to reduce their acoustic signatures. This technology, invented in Nazi Germany over 80 years ago, remains in use on the most advanced submarines operating today. In 1943, Nazi Germany developed acoustic homing torpedoes, weapons that could track and strike targets by detecting the sound of their engines. This was revolutionary torpedo technology that represented a significant advance in underwater warfare. The acoustic homing systems allowed the torpedo to be launched in the general direction of a target and then home in on the acoustic signature of the target vessel. This made the torpedo far more effective than conventional unguided weapons. These acoustic homing torpedoes were used with significant success against Allied naval vessels and submarines. The United States Navy was developing similar technology at approximately the same time, but the German acoustic torpedoes represented an independent development of this important military capability. After the war, acoustic torpedo technology was extensively studied and refined by both the Soviet Union and the United States. Modern anti-submarine torpedoes used by navies throughout the world evolved directly from the acoustic homing technology that was pioneered by Nazi Germany. Nazi Germany developed the first practical guided anti-ship missiles, weapons designed specifically to target and strike naval vessels. The Fritz X and Henschel HS-293 were radio-controlled missiles that could be launched from aircraft and guided toward their targets by radio command. These were not merely theoretical designs or prototypes. They were manufactured, deployed, and used in combat operations with significant effect. The development of guided anti-ship missiles represented a fundamental breakthrough in naval warfare. Traditional naval combat had relied on guns and torpedoes. weapons that required either direct line of sight or underwater travel to reach their targets. The Nazi-guided anti-ship missiles changed that calculus entirely. They could be launched from a distance, guided toward a target by radio command, and strike with precision that conventional weapons could not achieve. The Fritz X, also known as the Ruhrstahl X-4, was a guided bomb that could be controlled after release by the attacking aircraft. The pilot could observe the target and guide the weapon toward it, using radio signals transmitted from the aircraft. This represented a revolutionary concept in weapons delivery. The bomb could be released from an altitude where the aircraft was relatively safe from anti-aircraft fire. Yet the pilot maintained control over where the weapon ultimately struck. The Henschel HS-293 was similarly sophisticated. It was powered by a rocket motor that gave it significant speed and range. Like the Fritz X, it could be guided by radio command from the launching aircraft. The combination of speed, range, and accuracy made it an extraordinarily effective weapon. These weapons saw operational use in the Mediterranean theater, beginning in 1943 and continuing through 1944. The results were immediate and devastating. On September 9, 1943, German aircraft armed with Fritz X weapons attacked the Italian battleship Roma, which had recently switched sides and was attempting to reach Malta. The Roma was struck and sunk, the first major warship to be destroyed by a guided missile. The American light cruiser USS Savannah was struck by a Fritz X on August 11, 1943, suffering catastrophic damage that forced it to be withdrawn from service for extensive repairs. The USS Boise was also struck and damaged. Multiple other Allied vessels were damaged or sunk by these guided weapons in the Mediterranean. The significance of these successes was not lost on Allied naval planners. For the first time, naval vessels, even heavily armored battleships, were vulnerable to attack from aircraft at distances and altitudes where traditional anti-aircraft defense was ineffective. The weapons could reach their targets while the launching aircraft remained outside the engagement envelope of naval air defense systems. After the war, both the United States and the Soviet Union seized German-guided anti-ship missile designs and technical documentation. German engineers and scientists who had worked on these weapons were brought to the United States or recruited by the Soviet Union. The technology was extensively studied, refined, and developed into more advanced guided anti-ship missile systems. The guided anti-ship missile concept that Nazi Germany pioneered would become a cornerstone of naval defense strategy throughout the Cold War and into the modern era. The Exocet missiles that would later achieve notoriety during the Falkland Islands conflict, the Harpoon missiles that became standard equipment on American naval vessels, and virtually every guided anti-ship missile system that exists today owes its conceptual lineage to the research and development conducted by Nazi Germany during World War II. Nearly every nation with a significant naval capability now fields guided anti-ship missiles descended from or developed independently using the principles that were pioneered by Nazi Germany. The missiles themselves may have been refined over the decades, given modern electronics and improved guidance systems, but the fundamental concept, a guided weapon launched from aircraft or ships that can strike naval targets with precision, originated in Nazi Germany. The effectiveness of these weapons was such that Allied naval planners were forced to fundamentally rethink how naval warfare would be conducted in the future. The day of the battleship as the primary capital ship was ending. Aircraft with guided missiles would become the new arbiters of naval power. This transformation in naval warfare doctrine can be traced directly back to the success of the Fritz X and Henschel HS-293 in 1943 and 1944. Nazi Germany developed the Sturmgewehr 44, which is widely recognized as the world's first true assault rifle, a weapon that combined the rapid-fire capability of a submachine gun with the range and accuracy of a rifle. The STG-44 fired an intermediate cartridge, a cartridge that was more powerful than those used in submachine guns, but less powerful than those used in traditional rifles. This intermediate cartridge and the weapon designed around it represented a fundamental innovation in small arms design. The development of the assault rifle concept was born from practical military experience. German infantrymen found that traditional bolt-action rifles, while accurate at long range, were slow to fire in close-quarters combat. Submachine guns provided rapid fire but lacked the range and accuracy needed for medium-distance engagements. The Sturmgewehr 44 was designed to provide rapid-fire capability, combined with the range and accuracy of a traditional rifle. The St. G 44 featured a gas-operated system that cycled the bolt automatically, allowing rapid fire. It was chambered in the 7.92 by 33 mm Kurtz cartridge, a purpose-designed intermediate round that balanced power and controllability. The weapon was fitted with a selective fire system, allowing it to be fired either as a semi-automatic rifle for aimed fire or as a fully automatic weapon for suppressive fire. The development of the assault rifle concept fundamentally changed infantry warfare doctrine. No longer would soldiers be limited to either slow, accurate fire or rapid but short-range fire. The assault rifle provided both capabilities in a single weapon. This represented a paradigm shift in how small unit combat would be conducted. The STG-44 was manufactured in limited numbers before the war ended. Approximately 500,000 were produced, a significant number given German industrial capacity constraints in the final years of the war. However, even this limited production demonstrated the weapon's potential and importance to the German military. The design principles of the St. G 44 influenced rifle development worldwide. After the war, the Soviet Union seized German St. G 44 designs, technical documentation, and German engineers who had worked on the weapon. The Soviet designers, particularly Mikhail Kalashnikov and his team, studied the St. G 44 extensively while developing their own assault rifle design. The result was the AK-47, the Avtomat Kalashnikova model 1947. While the AK-47 incorporated improvements and modifications from the German design, the fundamental concept came directly from the St. G 44. The AK-47 used a similar gas-operated system, fired an intermediate cartridge, and provided both semi-automatic and fully automatic fire modes. The design lineage from the Nazi St. G 44 to the Soviet AK-47 is direct and is acknowledged by military historians and weapons engineers. The AK-47 became the most widely distributed assault rifle in human history, produced in the Soviet Union, China, and numerous other countries, and copied or reverse-engineered by countless nations. The AK-47 and its variants have been used in virtually every significant armed conflict since the 1950s. The weapon that defines modern warfare can trace its design ancestry directly back to the German Sturmgewehr 44 of World War II. The significance of this technological transfer cannot be overstated. The assault rifle has become the standard infantry weapon for military forces worldwide. The design principles established by Nazi Germany in developing the St. G 44 shaped the development of military small arms for the remainder of the 20th century and into the 21st century. It is estimated that more assault rifles have been produced based on or influenced by the St. G 44 design concept than any other rifle design in history. Hundreds of millions of AK pattern rifles exist worldwide. Each one represents a technological lineage that traces back to Nazi Germany's innovation in small arms design. In 1938, the German pharmaceutical company Temmler developed Pervitin, a methamphetamine compound intended for use as a military stimulant. This was not an accidental discovery or a chance byproduct of other pharmaceutical research. Pervitin was deliberately synthesized and developed with the explicit intention of enhancing military performance and capability. The German Army physiologist Otto Ranke recognized the military potential of the drug with striking clarity. Pervitin could keep soldiers alert and functioning on minimal sleep. It could maintain morale in the face of catastrophic military defeats. It could enhance physical endurance, allowing soldiers to march greater distances, carry heavier loads, and continue fighting after conditions that would normally lead to physical collapse. The drug essentially removed the normal biological limits on human performance. Ranke conducted research demonstrating that soldiers under the influence of Pervitin could maintain alertness and cognitive function during periods that would normally induce severe fatigue. The military implications were immediately apparent. A soldier who could function effectively for 36 or 48 hours without sleep, who could maintain mental clarity and physical capability under conditions of extreme stress and fatigue, represented a significant military advantage. Pervitin was distributed to German military personnel particularly pilots and other combat troops who required extended periods of alertness. Luftwaffe pilots received the drug to enhance their performance during long-range bombing missions and extended air combat operations. Panzer crews received Pervitin to maintain alertness during long-distance mechanized operations. Infantry units received the drug to enable extended operations and forced marches. Pervitin was incorporated into military rations, distributed as pills that soldiers could consume to maintain alertness and combat capability. The drug was distributed systematically throughout the armed forces, particularly to frontline combat units and specialized operations troops. It became, in effect, a standard component of the German military supply system. The drug's use became widespread among German soldiers, particularly during the invasion of France in 1940. Soldiers were reported to have marched 30 to 50 miles per day under the influence of the stimulant, distances that would normally be impossible to sustain without pharmaceutical assistance. Military records document soldiers maintaining combat capability for extended periods, under conditions of extreme stress and minimal sleep, enhanced by regular doses of Pervitin. Adolf Hitler himself became a user of pharmaceutical compounds containing methamphetamine. His personal physician, Dr. Theodor Morell, administered daily injections that included Pervitin mixed with other compounds. Over the course of the war, Hitler became increasingly dependent on these injections, receiving them multiple times daily. The drug was a component of a cocktail of substances that Morell administered, all intended to enhance Hitler's mental and physical capability despite his declining health. The long-term consequences of Pervitin use on individual soldiers and on the German military as a whole were severe. The drug created dependency and addiction. Soldiers who had been using the stimulant for extended periods developed withdrawal symptoms when supply was interrupted. Chronic use led to health problems including heart damage, psychological disturbances, and neurological complications. The high experienced initially gave way to crashes and dependency. The implications of wide-scale methamphetamine use on military populations were profound. Soldiers became addicted to the drug. Unit cohesion was affected as withdrawal symptoms created instability in frontline troops. The long-term health consequences would not become fully apparent until after the war, but the damage to individual soldiers was severe and lasting. After World War II, the use of methamphetamine as a military stimulant was discontinued by Allied military establishments, though not universally or immediately. However, the research into performance-enhancing drugs that had been conducted by Nazi Germany became the foundation for subsequent military and civilian research into pharmaceutical enhancement. The compound developed by the Nazi German pharmaceutical company, Temmler, Pervitin, became the basis for subsequent research into performance-enhancing drugs and the military's later exploration of similar stimulants. American military research into stimulants continued through the Cold War, producing compounds with effects similar to those of Pervitin. Soviet military research similarly continued the investigation into methamphetamine-based performance enhancement. The historical reality is that Nazi Germany pioneered the systematic use of methamphetamine as a military-enhancing drug. The scale of distribution, the integration into military supply systems, and the systematic administration to combat troops represented an unprecedented experiment in pharmacologically enhanced military capability. The long-term human cost of this experimentation was significant and lasting, but the research conducted demonstrated the military potential of performance-enhancing pharmaceuticals, research that would continue for decades after the war ended. Nazi Germany, cut off from natural rubber supplies through Allied blockades and unable to access the rubber plantations of Southeast Asia, faced a critical material shortage. Natural rubber was essential for the production of tires, gaskets, seals, and countless other military and industrial applications. Without rubber, modern mechanized warfare was impossible. Rather than accept this limitation, Nazi Germany committed substantial research and industrial resources to developing synthetic rubber production technology. The result was the development of Buna N and Buna S synthetic rubbers, materials manufactured from petroleum derivatives rather than harvested from rubber trees. The Buna N rubber was developed through the polymerization of butadiene and acrylonitrile. The Buna S rubber was developed through the polymerization of butadiene and styrene. These synthetic rubbers possessed properties that were comparable to, and in some applications superior to, natural rubber, They could be used in tires, seals, and other applications where the durability and chemical resistance of natural rubber were required. The production methods developed in Nazi Germany for synthetic rubber were sophisticated and represented significant advances in polymer chemistry. The technology required not merely the chemical knowledge to create the synthetic materials, but also the industrial infrastructure to manufacture them at scale. Nazi Germany established production facilities and manufactured hundreds of thousands of tons of synthetic rubber during the war years. This synthetic rubber production capability was essential to the German military effort. Without Buna rubber, the Wehrmacht's mechanized divisions would have lacked tires for vehicles and equipment. The Luftwaffe would have lacked gaskets and seals for aircraft. Naval vessels would have lacked the rubber components essential to modern warship construction and operation. The entire military apparatus depended on a steady supply of rubber, either natural or synthetic. After the war, both the Soviet Union and the United States seized German synthetic rubber production facilities and technical documentation. German chemists and engineers who had worked on the synthetic rubber programs were recruited by the Allied powers. The production methods and chemical processes developed by Nazi Germany became the foundation for post-war synthetic rubber industries worldwide. The technologies developed in Nazi Germany for synthetic rubber production were further refined and improved by American and Soviet researchers, but the fundamental processes and methodologies originated in German research during World War II. The synthetic rubber industry that emerged in the post-war period, which eventually displaced natural rubber from many applications, was built upon the research and development conducted by Nazi Germany. Similarly, Nazi Germany developed organosilicon materials and advanced plastics that were used in military applications. These materials represented significant advances in materials science and chemistry. Organosilicon compounds have properties that make them useful for high-temperature applications, waterproofing, and numerous other industrial and military applications. The research into organosilicon chemistry, conducted by Nazi German scientists, contributed to the understanding and development of these materials. Nazi Germany also conducted research into various polymeric materials that were intended for military applications. These included early formulations of what would later become known as plastics and composites. The research into advanced materials with properties superior to traditional materials like wood, metal, and natural rubber, was conducted with the explicit goal of supporting the German war effort. The production of these advanced materials represented a commitment of resources and scientific talent to address specific military needs. When traditional materials were in short supply or inadequate for military applications, Nazi Germany invested in the development of synthetic alternatives. This approach to material science, deliberately creating new materials to meet specific military requirements, represented an important methodological advance in how materials research could be conducted. After the war, the research into synthetic materials conducted by Nazi Germany influenced the entire field of materials science and chemistry. Modern advanced materials, polymers, and composites owe conceptual and methodological debts to the research that was pioneered by Nazi German scientists during World War II. Nazi Germany developed Perlon, a synthetic polyamide fiber, in 1937. This artificial fiber had properties that made it useful for military applications, where natural materials were in short supply or inadequate for the required applications. Perlon was manufactured and used in German military equipment throughout World War II. After the war, the technology was studied and adopted by numerous countries. Perlon became a standard synthetic fiber used in commercial applications worldwide. The development of Perlon represented an important advance in polymer chemistry and material science, research that was conducted in Nazi Germany. The German research into advanced propulsion systems extended beyond ballistic missiles. The Silbervogel project was a theoretical design for a suborbital bomber aircraft that would have been capable of reaching 90 miles in altitude and bombing targets such as New York when launched from Germany. The Silbervogel design never progressed beyond wind tunnel mock-ups and theoretical studies, but the research conducted on this project contributed significantly to the development of rocket and ramjet technology. The work done on the Silbervogel design continues to influence rocket and ramjet technology development today. German research into advanced propulsion systems and hypersonic flight was so sophisticated that it shaped the direction of aerospace technology development for decades after the war ended. These 15 technologies represent only a portion of the advanced developments that emerged from Nazi Germany during World War II. From rocket science to materials chemistry, from jet propulsion to guided weapon systems, Nazi Germany pushed the boundaries of technological possibility during one of history's most devastating periods. What remains remarkable is not merely that these technologies were developed, but how comprehensively they were seized, studied, and incorporated into the military and civilian technological infrastructure of the post-war world. The scientists, the engineers, the researchers who created these innovations were brought into Allied military and civilian research programs through Operation Paperclip and similar initiatives. The technologies themselves were subject to international restrictions, export controls, and classification systems that persist to this day. Some remain classified. Some were deliberately hidden from public knowledge. The reason was not merely to prevent their replication, but because their sophistication and their implications for future warfare were so profound that national security establishments deemed it necessary to compartmentalize the information. The space age that began with Sputnik and reached its pinnacle with the Apollo moon landings was built substantially upon Nazi rocket technology. The jet aircraft that revolutionized aviation in the post-war era were developed from principles pioneered in Nazi Germany. The guided missiles that became the foundation of modern military doctrine emerged from Nazi research. The uncomfortable historical reality is that some of the most significant technological advances of the 20th century emerged from Nazi Germany during World War II. The question of how to acknowledge these achievements while condemning the regime that produced them remains one of history's more complex moral and intellectual challenges. If you enjoyed this video, please like and subscribe to our channel so you never miss out on more history documentaries.